When most people see an infinite series like that one, they don't know what to do. But by the end of this video, that infinite series will be no problem at all. The ratio test is a very easy test to learn. Using the formula shown on screen, you can easily find out if your infinite series diverges or converges. The formula is the limit as n approaches infinity of a of n plus 1 divided by a of n, where a of n is the general term of the infinite series. If the result of this test is less than 1 and finite, then the series converges. If the result of the test is greater than 1 or infinite, then the series diverges. If the result of this test is equal to 1, then the test is inconclusive. However, this does not occur often, making this test very reliable when determining the convergence of a series. This will be our first example. The sum from 0 to infinity of n squared divided by 2 raised to the nth power. The first thing we have to do is put the general term into the formula. If you'll notice, I've already turned 2 raised to the n plus 1 into 2 times 2 raised to the n. Now what you want to do is break up the fractions into manageable portions as shown on screen. As you can see, I have separated 2 raised to the n divided by 2 raised to the n, as this is equivalent to 1. I have also separated out n plus 1 squared divided by n squared because as n goes to infinity, this will also equal 1. This leaves just 1/2 remaining, as n plus 1 squared divided by n squared and 2 raised to the n divided by 2 raised to the n are both 1. Since 1/2 is less than 1, this series converges. Woohoo! Our next example will be the sum from 0 to infinity of n raised to the nth power divided by n factorial. Again, the first step is to put the general term into the formula. As you can see, n raised to the n plus 1 power should be turned into n times n raised to the nth power. I have also turned n plus 1 factorial into n plus 1 times n factorial. Just like the last example, the next step is to break down the fractions into more manageable pieces. You should put n factorial over n factorial because this is equivalent to 1. You should also put n to the n over n to the n because this is also 1. That being said, only the limit as n goes to infinity of n divided by n plus 1 remains. This is also equal to 1, meaning that the result of this test is 1. Because the result was 1, this test is inconclusive. Well, this is just a quick recap. The formula is on screen once again. It's the limit as n approaches infinity of a of n plus 1 divided by a of n, where a of n is the general term of the infinite series. Other than that, just remember that if it's less than 1, it converges. If it's greater than 1, it diverges. And if it equals 1, then the test is inconclusive.